So VXLAN is just like a virtual extensible LAN. So suppose in traditional VLAN we have a support of 4096, right? But if you are using a VXLAN, we have a support of 16 million VXLAN. And it is mostly used in cloud environment, right? Now, so VXLAN is virtual extensible LAN, local area network, right? It is layer 2 in the layer T overlay tunnel. Why it is said that? Because the topology of the VXLAN is like this. It is just like a spine and leaf topology. These are the spines, and these are the leaves. And here, this is a
can you tell me what is the spine
routing protocol. Spines are the Nexus 9500 switches, right? And leaves are the Nexus 9300 switches. Okay.
So it's full meshed.
Yeah, full mesh. And between the Nexus spine and leaf, we use the underlay protocol, which can be EIGRP, OSPF, BGP, anything. So here it will be a layer 3 routing. Okay. So earlier what happens if you talk about layer 3 network, so this is a core switch and this is your access switches, yeah, right, and these are the trunk link, right, and here we configure the SVI, and then layer traffic comes from here and there. But if you compare with him, with this is all our spine switches, leaf switches, and all these links are layer 3 links, not layer 2. All the routing protocol runs over, and over that we configure a multicast. For why it is used? Because to reduce the flooding of the broadcast, multicast, and the unknown unicast packet. Okay.
So the leaves, all your servers will be connected to the leaf node?
Yes, all our services will be connected to the leaf switches. Okay.
All your servers.
Yeah, all our servers. So what is the benefit of doing that? I mean, configuring the layer 3 between spine and leaf, it don't have STP, right? By using multicast, we have reduced the broadcast packet, the flooding part. I mean, only the particular source which are going to send a packet to the particular destination, that part only be used. Third is we are using 16 million VXLAN instead of 4096 VLAN in traditional Ethernet. Okay. And because these are the layer 3 links, this supports equal cost multipath. Right?
Okay. So all the servers are connected to the leaf?
Leaf, yes. Okay. Right? So these are the very much benefits of using VXLAN. Okay. Now, so in the VXLAN there are two type of network. One is underlay network and one is overlay network. So what do you mean by underlay network? Underlay network is, suppose these are the spine and these are the leaves. Okay, and these are all layer 3 links. Right? And in between these, we use any of the protocol like EIGRP, OSPF, BGP. So once we run a routing protocol between them, we say as a underlay network. Right? Now, once underlay network is ready, right, we configure a VXLAN over it. So what it happens, a logical tunnel, VXLAN tunnel is created, point-to-point tunnel is created like this. So suppose this will be your tunnel, right? This will be your tunnel, right? So this, this network is called as an overlay network. So overlay network always runs above underlay network. I mean, before you don't configure a routing protocol between spine and leaf, you can't run the overlay network. So you connect the spine and leaf, run the routing protocol, make all the spine leaves are reachable to each other, and then these will be called as an underlay network. Now overlay network is, if you are configuring a VXLAN over your underlay network, they are called as a overlay network. Okay, it is just like, for example, we say that internet is our underlay network, and on the internet we configure the site-to-site VPN, right? Right. So we say as an overlay network. So internet is our underlay, and over it we are using a VPN, so we can say as a overlay network. So here also underlay network is my EIGRP, OSPF, BGP, right? And over it we are configuring a VXLAN. So VXLAN tunnel will be created between each of the leaves. So we will say as a overlay network. Okay.
Okay. So can you explain that part again? Sorry. What were you saying?
So VXLAN, if you configure a VXLAN over your underlay network, we will say as a overlay network.
Okay. Oh, okay. Configuring VXLAN on top of overlay, underlay.
Underlay, yeah.
Okay. I got it.
Okay. Now we have a certain new terminology. We say VXLAN is a virtual extendable local area network, right? VNI or VNID is virtual network identifier. Okay. It is same as a VLAN ID. So suppose you have a VLAN ID 96. So in the VXLAN term, we will say as a VNI. Okay. VTAP is your VXLAN tunnel endpoint. So suppose what happens, so this is your spine, right? And this is your leaf. So these leaves are called as a VTAP. Why? Because your tunnel starts from one of the leaves and ends on one of the leaf. So like this. So virtual tunnel endpoint we say. Right? VXLAN segment is obviously a layer 2 network. What do you mean by VXLAN gateway? VXLAN gateway is it can be a layer 2 gateway or a layer 3 gateway. I mean, when a traffic is forwarded between VXLAN, the device which forwards the traffic between VXLAN, we say as a VXLAN gateway. I mean, you can say as a inter-VLAN routing, so inter-VXLAN routing or a switching. Right?
Okay.
And what is NVE? Network Virtualization Edge, we say. NVE is Network Virtualization Edge. So suppose when we configure a VLAN, so we create a L2 VLAN and then we create a interface VLAN 10, right? So it is a logical layer 3 network. So same as if you configure a VXLAN 10, we configure as its layer 3 boundary, interface NVE1, we can say.
Oh, it will be the VXLAN.
Yes. It is a logical representation of the VTAP. I mean, it's a tunnel interface through which the tunnel will be created, and it's just like an interface tunnel you configure in a GRE, right? So it is same as the interface and the network virtualization edge. Okay?
Yeah.
Now, so how it works, the VXLAN works. So VXLAN works on the Ethernet, right? So what happens when a traffic, so let me say it like this. So when suppose this is your PC, when a PC sends a traffic to your leaf, I mean the VTAP, right? So before transporting into your overlay, what happens? Your Ethernet packet will be, a VXLAN header will be added. Okay, and over that IP header is added.
Mhm.
And then it is a CRC and then FCS. So these two header are added. So this corresponds to, I think, the 42 bytes,
Mhm.
right? So before your Ethernet, VXLAN header and IP header will be added, and then your traffic moves from, because why it is IP? Why? Because you are configuring the ERGRP and overlay here, right? So it's the same routing protocol. So for routing you need IP header, on the front,
Yes.
right?
Yes.
So then so it has a source IP and destination IP it contains. So let me talk when we will see the packet forwarding, right? So it's same. So it is a layer 2, your original layer 2 frame, then your VXLAN header, and then UDP header, and then IP header.
Okay.
Okay. So VXLAN header contains the the VNID part.
Mhm.
I mean the VLAN ID you say, right? So in the VXLAN term we say a VNID. UDP header contains the source UDP port and the destination UDP port. Right? So suppose a PC or a server sends a traffic, it will contains its source UDP port and to which destination port it is going. Right? So it contains. Outer IP packet is your source VTAP IP and the destination VTAP IP. Okay? Are you there?
Yeah. Go ahead. Yeah.
Okay. Now, let's see how the packet flows. So suppose this is your host A, right? Whose MAC address is A, IP is A, which is IP is 10.10.10.100, right? And your destination is B, IP is B, and your IP is 10.10.10.101,
Mhm.
right? So what happens as soon as your a PC is connected to the VTAP? So what it does, it learns the MAC address of your host, right? So it will, and your each VTAP has an IP address. So suppose this will have IP address 165.123.1.1.
What is VTAP again, sir?
VTAP is virtual, the tunnel endpoint. The leaf switches are called as a VTAP.
Oh, leaf switches.
Yeah, right. And this VTAP has an IP address, 140.123.1.1. And because you are running a OSPF EIGRP between leaf and spine, so these two IP will be able to reach to each other. Okay. Now, so our first step will be as soon as my host is connected to VTAP, the VTAP will learn the MAC address. Okay, and the MAC address and the IP, right? And the VTAP will send this information to VTAP2,
Mhm.
right? So in the MAC table, VTAP2 will have, I want to go to MAC A, I have to go to 165.123.1.1, right? And the same VTAP 1 will contains the MAC address of B, and it will say that okay, I need to go to MAC address B, I have to go to VTAP 2 IP address. It is same. It is same like the OTV we learned.
Mhm.
Okay.
Mhm.
Now, so suppose my host A want to talk to host B, right? So the source MAC address will be MAC A, destination MAC address will be MAC B, source IP will be IP A, and destination IP will be IP B, right? Now when a packet reaches here, the VTAP A will see, okay, I want to go
so
to...
VTAP is the leaf, right?
Yes, leaf. Now...
Okay. And all your PCs and your servers connect to the leaf node. So
yes.
Right. So leaves connect to the spine, full mesh to the spine. Every leaf has got every connection to the spine.
Yes.
And the leaf, you have a host or a PC or a server or a printer or a plotter connected to the leaf switch. Okay.
Yes.
So leaf switch, is there a Nexus switch?
Yes, Nexus 9300.
Nexus. It's not a normal layer 2 switch.
No.
Okay.
Okay. So as soon as...
So it's a Nexus leaf would be a Nexus switch.
Yes.
Okay. Spine also will be a leaf switch?
Yeah, spine also will be Nexus 9500.
9500. Oh, okay. Okay, so both the spine and leaves are Nexus switches. Okay.
Yeah.
Okay, and all the servers are connected to the leaf switch, servers and workstations.
Yeah. So as soon as your host A will send a packet to VTAP A will check, okay, what is my destination MAC address? Destination MAC address is MAC B. Now it will check its MAC table. For the MAC B, where I have to go? I have to go to this IP, 140.123.1.1. So it will create its VXLAN header. So this is your Ethernet header. That it is your VNID, VXLAN ID. Suppose it is in VXLAN 10. Right? UDP port, and see what our outer destination source ID. Source ID is IP address of this one. So the source ID will be 65.123.1.1 and destination will be 140.23.1.1. So with this IP, it will be routed. Why? Because you are configuring a ERGRP or PGP between your leaf and spine, right? So your packet will reach to here. Okay, and then this packet will be, decapsulated. I mean, the packet here will be decapsulated, right? And your original packet, Ethernet packet will be handed over to host B. So this is how a packet flows in, a VXLAN. Okay. Now the configuration point of view, there are some steps. So on each leaf switches you have to configure. I mean, first step is configure EIGRP, OSPF, BGP between leaf and spine. First thing, so that all are reachable to each other. Then second step is configure VLAN with VXLAN segment. So you go to the VLAN 10 and then you write VN segment. Its corresponding VXLAN will be suppose 5100. So now what you are saying?
So VN segment is what?
VXLAN, VNID.
VNID. So this is VNID.
Yes.
VX segment.
Third, on the third part, you have to configure a interface NVE. So what you will say here? Interface NVE1, right? Source IP address will be the IP address of the VTAP. So you can say that any IP address of the VTAP. Suppose I say which will be configured on the VTAP, right? And then you say VXLAN 5500 multicast address will be 232.2.2.2, anything you can write, and then you configure a no shut. Right. So these are the configuration we can do in the VXLAN part on each of the VTAP.
Okay, now VLAN is the VLAN segment.
Sorry,
Identifier.
5100 is identifier.
Okay, and you have to give the IP address under NV tab.
Yes. Yeah. I mean the source address. Source IP address.
Source. Okay. Okay. And 232 is the address on the other side, right?
No, 232 will be the multicast address.
Multicast address. Ah, okay. Okay. So it's not the address. Okay. Okay.
No. Why multicast address? Because the control plane will be control plane will be synchronized to this IP address only.
Yeah, tell me. Yes, sir. Go ahead.
So the control plane will be synchronized to this IP only. I mean the control packet. I mean as soon as the MAC address is logged on the VTAP will send its MAC address information to the another VTAP via this address only. So this is your very brief and VXLAN overview.
Can we do this in the configuration or?
Sorry?
Can we do this in the LAN? Can we do this LAN?
Actually, VXLAN lab we have not integrated till now because we are not getting the license for that. So it's under development. So I mean, so we can't do that. That is, otherwise I would have shown you how to configure and how to create each other part. But I will send you the PDF of the configuration. You can have it for your future use.
So you have any good notes on VXLAN that I can?
Yeah, I'll send you.
Okay. Okay. I just want to know, sir. I need last Saturday's.
Yeah, that I will send you today only.
Yeah, I think last Saturday's class and also the configuration we did last Saturday. Configuration, OTV configuration.
Okay, sure. I'll send it to you.
Okay. And also, can you just give me some good notes about on VLAN vehicle so I can read it when I'm.
Sure. I'll send it to you.
Okay, so these are the three things, sir. If we can. So tomorrow can we cover FLEX and VDC?
Yeah, let me check with Deepak. I'll no problem because he updated me only